As when I look at today's lesson, it's really just an extension of yesterday's lesson. It is a direct application of yesterday's lesson. So that's why you didn't have a homework video to watch. That's why we didn't do a quick check today. I want to make sure that we give you guys yet another day. Take some time, learn the trig, see it one more time in a different perspective. So tomorrow we actually will do our quick check on trig ratios. When we look at this, really, our objectives are fairly straightforward. Talking about angles of elevation, angles of depression. Using trig. It's a very simple deal. If you can draw a picture, then you should be all set. But you have to be able to read a question and read through the context and understand or try to visualize what you're being asked to do. That's the hard part. So first, let's define these. The angle of elevation, I mean, you can write down all that crap if you want, but you don't have to. It's very simple. Angle of elevation, straight line of sight, you're looking up. That's angle of elevation. At what angle do you have to tilt your head to see something in the sky? That's angle of elevation. That's always relative to the line of sight. Keep that in mind. Angle of elevation and angle of depression are based on the line of sight. So angle of elevation, you're looking up. Angle of depression, you're looking down. You would think so. But just in case we have a hard time trying to remember which ones are which. So when we look at putting these things into a problem, all you gotta do is draw a right triangle. That's all we're doing. So let's go ahead and take a look at our first example. From the top of a tower, the angle of depression to a stake in the ground is 72 degrees. If the tower is 80 feet, how far from the foot of the tower is the stake? Now, to you guys, you might think, okay, this is really ridiculous. Why don't you just get out a meter stick or some kind of tape measure and actually measure out how far it is? No need to do the trig. But take yourselves out of the classroom and put yourself in a real situation. If you're part of the crew that has to actually erect the tower, don't you need to know where to place that stake ahead of time? The engineers are the ones that will tell you that the line needs to be at a 72-degree angle. It's your job as part of the crew to figure out then how far to put that stake out. So you need to be able to do some of this. And it's truly difficult. So we have this really tall spire of a tower. And again, this is where you guys can have a little bit of fun. And there's my little tower. Think of it as like one of those blinking towers, right? So here's my top, and we got this little light bulb. So there's my tower. And now, how tall is my tower? 80 feet. Okay. So this is the top of my tower. Here's my line of sight, straight out, right? Well, I should make that look a little better. Let's go ahead and use this line right here. So there's my line of sight, correct? And then down here at the bottom, I have the ground. So here's my ground. And somewhere in the ground, I have this anchor. Stake sitting down there in the ground. And then, so I have my line going from the top of the tower, anchored to the ground. It's not that difficult. There are those pictures, is it? Pretty straightforward. Okay, but now we look at this and we say, all right, I can actually draw a right triangle by taking this line and going straight down. Did I not just create a right triangle? Okay, that's the important piece. So this is our right triangle. What is the angle of depression? That's looking down, so that's this angle right here is 72 degrees. What are we trying to figure out?
How far you have to get the stake from the tower.
Alright, so I'm trying to figure out that distance, right?
Yeah.
Okay, what shape do I have Right here. Or rectangle. What do you know about opposite sides of a rectangle? They're congruent. So if my bottom length, the ground distance is x, what's the length up here? It's also x. It's our unknown distance when we're trying to solve for it. How tall is my tower?
80 feet.
80 feet. So what does that make the height over here? And now you focus and see the right triangle. Which trig function is this going to be? Yeah, notice we don't have our hypotenuse length, do we? All we have is the opposite side and the adjacent, which is therefore tangent. So part B, solve it. So the tangent of 72 is equal to what? 80 over x. And you guys remember what we learned yesterday? When the x is on the bottom, what do? You flip it. Okay? So we get x is 80 over tangent of 72. And that's where you go to your calculator, where you have the scientific calculator, graphic calculator, doesn't matter. Put the angle inside the function. And I came up with 84.17 feet.
Okay, so the first one that you get that's like 80 over,
So you're going to take 80.
no, wait, is that your exact answer?
Yeah, this right here is your exact. This is your approximate.
How do you how would you calculate
80 division tangent 72.
it?
Yeah, that's 25
Is mine stuck? Oh, shoot, yeah, this is the one I was using a calculus. I'm probably in reading mode. Let's try that again, shall we? Yep. Hey, look at that.
Yeah, look at that. Thomas is wrong.
I got 25.99.
I agree. 25.99. My mistake on that. I was definitely in the wrong mode. So almost exactly 26 feet.
How do you know if coordinates between
It basically you have to read instructions. If it wants you to run to the nearest 100, it'd be 25.99. If it says the nearest whole, then that would be 26. All right, I'm going to do one more example with you guys. All right, let's do this one. Justin is flying a kite, lets out 55 feet of string. Okay, and you guys see a little boy flying a kite out in the middle of the field.
About ready to get hit with a bolt of lightning, yes.
What?
Very sick.
What a piece of
Not that I disagree with your assumption.
Or
That
like
would
Thomas
be
had said
fine.
with the light bulb thing.
We're hitting the face with the
Franklin.
Okay.
All right, so let's draw a little picture. So here we have little Justin sitting right here, okay. And Justin's holding onto this kite, and the kite goes off at an angle, right? Your kite doesn't sit directly above your head,
Kind of.
and unless you're Charlie Brown, it's probably not sitting on the ground or in a tree
We're on your back.
or on your back. So it's definitely going out. It's at some type of an angle, right? So up here we now have our kite, and thanks to our quadrilaterals unit, you guys should now be able to draw a kite. And you might want to make it look pretty. We'll put some little bows on the kite's tail.
It's Justin's kite.
Yeah, come on. Oh, wait.
There we go. You probably got the little crosshairs. Yay, I'm flying a
Is there a
kite.
problem with your tail was just like straight down, not? See
My
mine.
kite was actually good.
Why is your tail tucked
Mine
in
too.
your back?
Look at mine.
Alright, so anyways, so we look at this, we say, hey, we kind of had the same concept, right? If we're basing this with the angle of the ground, what can you guys tell me about this line and that line.
That's
But parallel.
Yeah.
So if I'm making, think about extending that. If the angle is 35 degrees to the ground, what's this angle then?
35.
It's also 35. And then we have another straight angle going up. And what have we created?
Right.
A right triangle.
Right triangle. Yeah. Right.
Now let's talk about what we have. What do we know? Well, we know that we have 55 feet of string. So what does that tell us?
Hypotenuse is 55.
The hypotenuse is 55.
So it would be
What are we trying to figure out?
sine of the
Cosine.
How high the kite is. So where does that go?
Right underneath the kite.
Right underneath the kite. That's our h. Okay, start using variables that make sense to the problem. You don't want to use, we could use x, but basically h for height. Now, which trig function do we have here?
sine
Why is it sine, Connor?
opposite over
Which side is the opposite?
h.
H, okay. So the sine of the angle is the opposite side over the hypotenuse. How do I solve for h?
Times by 55.
Multiply by 55. So h is 55 times the sine of 35.
Rewind. Got from 1 point.
I got 31.55.
1.546.
Now, guys, in this particular problem, we can say, okay, we're pretty good here, just leave it alone. But there are some other things here. Is this really how high the kite is?
No.
No.
Why not?
It's
Because we
not.
went from the distance from his hand.
We went from the distance from his hand to the distance of the kite. So we don't technically have the height of the kite. On problems like this where it doesn't give you that extra information, that's the answer you're looking for. But then sometimes you gotta go back and read it. Maybe it'll tell you that he's holding it, the string at a height of 3 feet above the ground. So what would you have to do then? Add it back in. So in that case, our height would be 34.55 feet. Okay? So like I said, you really got to look at it. Sometimes the problems are just really simple. Sometimes they'll throw that information in there. All right, that's all I have. We're done.
Can you turn it back to the first slide?
Yeah, give me a second. Stop that.